In this video, I want to talk about the physical and chemical changes that matter can experience. Remember that matter has both physical and chemical properties. Physical properties are things that you can observe or measure without changing a substance, and they include such things as color or density or how shiny something is, the luster, or whether it can conduct electricity, whereas chemical properties can only be observed during or right after a chemical reaction because they require a change in the substance. Some common chemical properties are combustibility, or the ability to react with oxygen and create heat and light, toxicity, danger to living things, or acidity. Matter, along with having properties, can experience changes. And so we're going to talk first about physical changes. A physical change affects the form of the substance, what it looks like, but it does not change the molecular structure. So there's nothing changing on the very essence of the substance. What the substance isn't being changed. Common physical changes can be caused by a change in temperature, which leads to a phase change, or we also call this a change in state. So we've got our ice cubes over here and they're melting. That's a change in state. It's going from a solid to a liquid. And then over time, this liquid probably will evaporate if the room is warm, turning from a liquid to a gas. So again, another phase change or state change. Another physical change is just a change in size by cutting or crushing something. And something that many people don't realize is just a physical change is dissolving a substance. It appears that this substance has disappeared into a liquid. So say we have some salt crystals here on the bottom of a beaker, and we add some water and stir it up, and then we see what looks like water because we can't look on the atomic level. We can't see these little particles of salt. In reality, the salt has not stopped being a solid. It has just been pulled apart as it dissolves in the water. And so the atoms are so spread out, we cannot see them as a pile, as a solid piece anymore. If we evaporate it off the water, the salt would reappear. So dissolving also is just a physical change. But then we get to chemical changes. And chemical changes, we have a change in the molecular structure of the substance. Something happens on the inside to rearrange atoms and form new substances with new properties. Most chemical changes are irreversible. They can't go backwards, but there are some that can be reversed, and you'll learn about those later on in this course. Chemical changes produce evidence, which is a handy thing because we can look for this evidence to see if a chemical change has occurred. One common evidence is a change of color. So here we have a clear liquid in one beaker being mixed with the clear liquid you see in the other beaker, but we definitely have a color change because we see yellow substance forming as those two clear liquids come together. So that lets us know a chemical change has occurred. A second piece of evidence that a chemical change has occurred is the production of a gas. And often along with the gas comes an odor, a smell, because our nose works by having receptors that can pick up molecules of a gas that are floating around in the air. Signs that a gas is being produced might be bubbles, or sometimes you hear a little bit of fizzing, and you also can sometimes even see vapor being released from the top of the flask or the beaker, depending upon what gas is being produced. Another bit of evidence for a chemical change is that light or heat energy is given off. And so these glow sticks that I know you're familiar with are actually a chemical change. A chemical reaction is happening inside those sticks, and that is why we are able to have that light showing. And then finally, the last piece of evidence for a chemical change is that a new solid, what's known as a precipitate, is formed when you combine two liquids. So in this example over here, you can see this orange solid forming in the clear liquids that are in the test tube. Drops have been added to cause this to form, combining two solutions. And if you wait long enough, this actually will sink down to the bottom of the test tube and collect in a solid layer on the bottom. So a precipitate is a solid. Now, chemical changes always require a transfer of energy, and we are able to track that transfer of energy as a change in temperature because sort of a side effect of energy transforming from one place to another is that heat is given off or heat is absorbed. So heat moves whenever energy is changing. Some common examples of chemical changes that are making a discernible change in temperature is the cold packs that you can get in first aid kits actually are absorbing energy from the environment, which is why they feel cold to you, because they are absorbing energy from you to fuel that chemical change. And combustion, of course, otherwise known as fire, clearly releases energy in the form of heat and light, quite a bit of heat, often. While all chemical changes require a transfer of energy, only some physical changes do. Evaporation, cools you when sweat evaporates off your arm, and that is because evaporating is a transfer of energy. It causes the cooling because it's taking the energy from your hot body and using it to make a change of state in your sweat from a liquid to a gas. So energy is being absorbed during that change. Freezing is actually the opposite. Freezing is a warming process. You wouldn't notice it normally, but it is a technique that's used by agriculture sometimes when there is a threatened freeze in the springtime and fruit might be on the strawberry plants or peach trees might have blossoms. Farmers may sometimes have a water misting on the plants, and so if freezing happens, it will cause a little bit of warmth actually to go into the plant. And then finally, dissolving, mixing a solid into a liquid such as water, can be either a warming or cooling process. It can either absorb energy or release energy. So just to review, physical properties can be observed without changing the substance because physical changes only affect the form of the substance and don't change its deep molecular structure. In contrast, chemical properties can only be observed during or right after a chemical reaction, and chemical reactions cause a chemical change.